Welcome to my YouTube channel, A Brainery of Civil.
Today I am going to solve the fourth assignment of Foundation Engineering. Okay, first question. What would be the influence factor of rectangular rigid foundation of L by B ratio equal to 10? So that is, influence factor will be useful in calculation of immediate settlement. Okay, so now for rigid footing, having L by B is equal to 10. So, influence factor value based on L by B ratio. So, IF value will be 1.06 if L by B is equal to 1.5, and IF will be 1.2 if L by B ratio is 2. Clear? And IF will be 1.7 if L by B ratio is 5. Now, IF will be 2.1 if L by B ratio is 10. If L by B ratio is 100, then IF value will be 3.40. So there is a table in the presentation. Here, what he asked, L by B is equal to 10. That is, L by B is equal to 10. The corresponding influence factor value is 2.1. Clear? So option C for question number 1. Next question. A plate load test was conducted on a clayey stratum, that is, test was conducted on clay soil using plate of 0.45 meter, and the plate's ultimate load carrying bearing capacity was found to be 250 kilopascal. The ultimate bearing capacity of square footing of size 5 meter by 5 meter would be. Clear? So, whenever we conduct a plate load test on a clay sample, if we got the ultimate load capacity in the plate load, the same ultimate load carrying capacity or ultimate bearing capacity will be the value for footing also. There is no change if the sample is related to clay. Clear? So the answer is 250 itself. Okay. Option A for question number 2. For question number 3, if the settlement of a plate 0.45 meter was, that is SP is equal to 5 mm under a pressure of 200 kilopascal in the cohesionless soil, that is related to, it is a sandy soil. Cohesionless soil means it is a sandy soil. What will be the settlement of 5 meter by 5 meter square footing at the same pressure and the same soil deposit? Clear? We have a formula for this. SF by SP is equal to BF by BB into BB plus 0.3 BF plus 0.3. So for this it will be square. So based on this formula we can able to calculate the value of settlement of footing by using settlement of plate. So that is SF by 5 mm, it is given value 5 divided by 0.45 into 0.45 plus 3, 0.3 divided by 5 plus 0.3. So you will get SF as 12.36 mm. Clear? So answer D for question number 3. Now, two footings, one is a square footing and other is a circular footing, are founded on the same depth and same purely cohesive soil, that is cohesive. Pure cohesive soil will have angle of internal friction is 0, and when angle of internal friction is 0, NQ and N gamma values are these values. NQ is equal to 1 and N gamma is equal to 1. In this, the ultimate bearing capacity QU is equal to 5.7 C plus gamma D. So when they are calculated, when they are found at same depth, so D is same and gamma is same, and C value when they are conducted on same sample, that is C is also same. The ratio of their ultimate bearing capacity, whatever be the dimension of a square or circle, whatever, it is independent of the dimensions. Clear? So now QU square divided by QU circle is equal to 1. Simple. It is not depending on the dimensions. He has given some different dimensions. That is, the diameter is twice the size of the plate. in the square. So irrespective of the size of the plate, so the ultimate bearing capacity will be same. Okay. So now option D for question number 4. Next question. Immediate settlement is measure for which type of following soil? Obviously, clay related soil will take certain time to dissipate pore water pressure. First of all, whenever we apply the load, solids will take the load. After that, liquids. So that is generally liquids will take the load at the starting. After this load carried by liquids, it will transfer to solids. It will take some time and there is a chance of development of pore water pressure. Okay. So but immediate settlement is the settlement within no time. So that will occur generally in granular soil. Okay. Option B for question number 5. Next, find the immediate settlement for an isolated concrete footing. So he has given the data 2 by 2 footing and depth is equal to 1 meter and modulus of elasticity is equal to 24500 kilonewton per meter square and pressure P is equal to 150 kilonewton per, that is bearing capacity, kilonewton per meter square. Then generally I will take it is a cube and mu is equal to 0.13. Is it 0.12 or 0.3? It is 0.3, it is not 0.13. And influence factor IF is equal to 1.12. So no correction is required. Directly you will get substitute in the formula. So immediate settlement SI is equal to QB into 1 minus mu square into influence factor divided by ES. So substitute, it is 150, P is 2, 1 minus 0.3 square and IF is 1.12 divided by ES is equal to 24500. So it will be 0.01248 meters. So it will be 12.48 mm. Direct formula में डालो, you will get the answer 12.48. Answer A for question number 6. Next question. Influence zone of loading in a particular footing for calculation of consolidation settlement. Whenever we are using settlement under consolidation, we are required to calculate settlement under consolidation. First of all, we need to take the influence zone as 2 into width, twice the width of the footing, and if there is a hard rock below the footing, until that depth only we will take, that is up to rock or rigid surface. Okay, so whichever is minimum out of these two, minimum value, that is option A correct, option C correct. By that you will get minimum of A and C. So option D is correct answer. 7 option D. And now question number 8. So he has given a footing. So this is 3 by 3 footing. Over this footing there is a clay layer. So 4 meters. So we need to calculate compression index is equal to 0.3. Initial void ratio is equal to 0.75. So at the center we need to calculate consolidation settlement. Okay, and the pressure here it is 45 kilonewton per meter square. Clear? So now consolidation settlement delta H is equal to Cc by 1 plus E naught into H log sigma naught bar plus sigma delta sigma bar. Okay, so first of all we need to calculate sigma naught. So sigma naught is equal to, the groundwater is somewhere here at the ground, that is gamma submerged he has given, it is 8 and this depth it is 1.5. So at this point we need to calculate, so 8 into 2 plus 1.5. So this will get, it is 28 and delta sigma is equal to 45 into 3 into 3. I have converting the pressure into load and so B plus Z will become 3 plus 2, it is the depth 3 and width is 3 plus 2 plus 3 plus 2. So you will get it is 14.4. So whenever you substitute this formula, 0.3 divided by 1 plus 0.75 and H layer will be 4 meters, it is 4000 and log sigma naught is equal to 28 plus 14.4. You will get it will be 123.57 mm. So the nearest option is 123.57. So option B for question number 8. Next question. Which is not time dependent settlement? Obviously, primary settlement is the most important settlement which need to be takes place by dissipation of pore water pressure. The dissipation of pore water pressure will take months and years. Okay, so primary settlement is time taking, and secondary settlement is readjustment of the solid particles. This readjustment of the solid particles will take many more number of days. It is also time taking. And immediate settlement within no time, hardly 1 or 2 days, not even 1 or 2 days, within no time it will be it will occur. So that is not time dependent settlement, is immediate settlement. Clear? So the answer is C for question number 9. And coming to last question of the assignment, if the settlement calculated from plate load test, S is equal to 10 mm and water table correction CW is equal to 0.6, then actual settlement X actual will be S divided by CW, that is 10 divided by 0.6, it will be 16.67 mm. Clear? So the answer is A for question number 10. Okay, this is the end of the assignment. If you have any doubts, post your comment. Actually, so many guys are asking so different subjects, something like seismology and bridge engineering. Actually, I want to say sorry for all these students. By next time, I'll take your request, which subjects you are enrolling. I'll try to give all the solutions for your required subjects. Okay, thank you.